Good morning, everyone. My name is Andrés Ondo. I'm from Polytechnic University of Valencia. Today, I will talk about challenge-based and gamified learning in energy market courses. This paper presents the design of challenge-based and gamified intervention for an undergraduate energy market course. The central idea is to let students experience the consequences of market decision while keeping technical reasoning, assessment, and reflection at the center. This is a prospective design. The intervention has not yet been implemented, so I will focus on how it is structured and how we plan to evaluate it. Electricity market are socio-technical system. Students must combine engineering constraints, economic incentives, regulation, and uncertainty. They can learn the clearing algorithm on paper, but static exercise rarely shows how one team beat change price, dispatch, revenue, imbalance exposure, or the opportunities are available to others. The teaching problem is therefore not only calculation, it is helping students connect an individual strategic decision with system-wide outcomes. Simulation create that feedback loop. The proposed intervention combines three layers. Challenge-based learning provides authentic, open-ended problems and student agency. Simulation provides immediate market feedback, such as price, dispatch, revenue, imbalance costs, and system indicators. Gamification makes progress visible and supports experimentation, but it is deliberately bounded. Points, badges, missions, and rankings are not the learning objective. The design rule is a constructive alignment. Every challenge and every mechanic must be linked to an intent outcome and to observable evidence. Each challenge follows the same learning cycle. Teams first receive the market rules, role-specific information, and a daily variable. They submit bids or design decisions. The simplified platform clears the market and returns both commercial and technical indicators. Teams then interpret what happened during a structured debrief and redesign their strategy. Recoverable failure is intentional. A poor bid is useful if students can explain the causal mechanism and improve their next decision. The following challenge repeats the cycle with more complexity or a new market condition. The sequence begins with an onboarding round and a transparent baseline market. Challenge 1 introduces strategic day-ahead bidding. Challenge 2 adds renewable forecast error, imbalance, settlement, and risk. Challenge 3 adds scarcity, storage, and demand response. In the final challenge, students stop adapting to a fixed rule and instead act as market designers, proposing and testing a flexibility mechanism. Roles rotate so every student encounters commercial and system perspectives while the required evidence progress from a first bid to a defended design proposal. Gamification is used as feedback architecture, not as substitute for assessment. Point and performance graphs show the immediate consequences of decision. Badges recognize demonstrated competence. The leaderboard support comparison, but it is anonymous and multidimensional. Optional missions are lost text and carry no grade penalty. Individual reflection provides evidence that cannot enter from team profit. The provisional rubric therefore weighs technical correctness, interpretation, strategy, and risk reasoning, written justification and reflection rather than ranking position alone. Because the intervention has not yet implemented, the evaluation plan is part of the contribution. The pilot asks for questions: whether students engage behaviorally, how they perceive motivation, relevance, collaboration, and competition, whether the artifact demonstrate technical understanding and higher order reasoning, and which design elements should be retained or revised. Evidence, combined logs, a conceptual test, service, bid files, reports, reflection, focus groups, and the teacher log. The analysis emphasizes transparent descriptive evidence and uncertainty before stronger effectiveness claims. The contribution is therefore a transparent and reusable instructional design, not evidence that the intervention already works. The challenge cycle, rotation, rubric, safeguard, and evaluation protocol are ready for a pilot. Learning gains, motivational effect, workload, accessibility, and the balance between competition and cooperation remain empirical questions. The next step is to run the classroom pilot. Triangulate behavioral, affective, and cognitive evidence, and revise the mechanic before wider adoption. This is how the proposal becomes a testable and transferable model for energy market education. Thank you for your attention.